All right, welcome to the final video of these 6 videos where I'm solving the end of year test questions. This is paper 2 and it is the questions that I consider to be the hardest ones. It's number 5, 6 and 9, all of them in section A because we did all of section B in the last video. And they are only 22 marks, which means that you can actually get a grade 7 on the end of year test, and you would be fine with almost a grade 6 without solving any of these. But of course, it's way more fun to be able to solve the really hard questions. So we'll dive into them. But before we do that, let me answer all the questions that you might have, because the answer is yes, I am currently in Spain. And yes, this is the Atlantic Ocean behind me. And yes, I'm in a bar. Where you get these weird little tapa things. This is an asparagus on a piece of bread with a bit of mayonnaise on top whenever you order a beer. So I'm celebrating the final video in the series. But enough talk, let's dive into question 5. There. So this is a binomial expansion problem again, and they are never easy. And this one is particularly tricky. And it's pretty nasty to have it on a section A where you think all the questions are supposed to be easy. And it's only a 7-minute problem, like 7-mark problem. So you're supposed to actually be able to finish it off in 7 minutes. Let's see how this goes. We're being told that the expansion of ax to the third plus b raised to the power of 8. That the coefficient of x to the power of 6 in that expansion is 448, and the coefficient of x to the power of 6 in the expansion of the same thing, but now raised to the power of 10. It's a bit hard to read, but if I'm zooming in, you can see it easier. So it's not just a binomial expansion, it's 2 different binomial expansions. But how to attack it? Well, we just do the expansion. So let's do the expansion of the first one. If we take ax to the third plus b raised to the power 8, then of course, and you should try and get to a point where this just happens automatically. Of course, we can expand this as a sum where we can call it k going from 0 to 8. And each time we have the binomial coefficient 8 choose k multiplied with ax to the third raised to the power k. You could also choose 8 minus k, but this turns out to be nicer because this is the one where x occurs. Times, yikes, I was just about to write plus, must be the beer, times b to the power 8 minus k. And we have information about the coefficient of x to the power of 6. So I want to know when this term has a power of x, that is 6. And I can already see that that is when k is equal to 2, because then x to the third will be raised to the power 2, and you'd get x to the power of 6. So I'm just going to say I take the k equals 2 term, which is 8 choose 2, of course, times a squared times x to the third to the second power, that's x to the 6, times b to the 8 minus 2, that's 6. And we can work a little bit on this. 8 choose 2, that's 8 times 7 divided by 2, so that's just 4. 4 times 7, that's 28, times a squared times b to the 6 times x to the 6. And our information is that the coefficient, that's this guy, is equal to 448. So first equation is that 28 times a squared times b to the 6 is 448. I'm going to put this in a box, because if I can get one more equation, then I'm pretty happy. And yes, where do I get that? from the other piece of information. So now we do ax to the third plus b, but now raised to the power 10. And that's a binomial expansion, k going from 0 to 10, and then it's 10 choose k times ax cubed to the k times b to the 10 minus k this time. And again, I want the term where the power of x is equal to 6. And again, I can see that that requires k to be 2. So I take k equals 2 term, and then I get 10 choose 2 times a squared x to the 6 times b to the, now it's 10 minus 2, so that's 8. And we can work on this. That is 10 times 9 divided by 2, so that's 45 times a squared times b to the 8 times x to the 6. And again, this guy is the coefficient of x to the 6, and we know that it's 2,880, so my second equation is that 45 a squared b to the 8 is equal to 2,880. Let's put a box around that. We have two simultaneous equations with a and b unknown, so we should be able to solve them. One really nice trick is to see that if we take this term, this stuff here, and we divide with the left-hand side up here, then the a squared goes away, and the b to the 8 gets divided by b to the 6. So it just becomes b squared, and that's pretty nice. So I'm going to do that. I'm going to say 45 divided by 28 times just b squared. That's equal to 2,880 divided by 448. So b squared is equal to 2,880 divided with 448 times 28 divided by 45. And you know, if I wasn't drinking a beer, then I would have a lot of fun doing this just in my head, because probably it can be simplified a lot. But then again, this is paper 2, and I still have my calculator running. Oh, I'm on top of the calculator, so I'll just move over here. And we clear the screen, and we say 2,880 divided with 448. And we are multiplying this with 28 and dividing by 45. And that's 4. So b squared is 4. And we can conclude that b must be the square root of 4, well, plus or minus, so that's a plus or minus 2. But we are being told up here that both a and b are positive, so we can conclude that b is equal to 2. And now we know the value of b, it's 2, so we can just put that into any of the equations. I prefer the first one, so I'm going to say that 28 times a squared times 2 to the 6 is equal to 448. And that means that a squared is equal to 448 divided by 28 times, what's 2 to the 6? Isn't that 64? And I can't do that in my head. So it's 448 divided with 28 divided with 64. I hope this goes well. Yeah, it's equal to 1 over 4. So a must be the square root of this. And again, since a is positive, it's not the negative square root, so a is 1/2. Question 6 is a lovely question about complex numbers, and it's probably the hardest question, if you ask me, in the entire paper 2. We're given a number set that is equal to the cosine of 11 pi over 18 times I plus I times the sine of the same angle, luckily. So that means that we can start out by writing this nicer. That z is actually what we call cis of 11 pi over 18, or if you prefer, which I do, it's the exponential e to the I times 11, times 11 pi over 18. And we have to find the smallest value of n such that z to the power of n equals minus I. So the nice thing about having z in this polar form, as we call it, where we know the polar angle and the modulus, which is 1, is that raising to powers is very, very easy. So z to any power is really just cis of n times 11 pi. I can't spell 11. Is 11 pi over 18. And we want that to be equal to minus I, which we also know is equal to cis of, let's see, minus I. So that's 3 pi over 4. No, wait a minute, not over 4, but 2. So when are these two the same? For which values of n would these be the same? Well, the polar angle of a complex number can be different and give the same complex number, but only if the two polar angles are separated by a whole number of 2 pi. So what we know is that if these two are the same, then n multiplied with 11 pi over 18, this angle, must be the same as this angle, 3 pi over 2, plus a whole number of 2 pi, where t is an integer. We can simplify this a bit by first dividing with pi, so pi just disappears in all terms. And then also I would like to multiply with 18 on both sides. So I get that 11 times n is equal to 18 divided by 2, that's 9, times 3, that's 27, plus the pi goes away and the 2 gets multiplied with 18, so that's 36 times t. And again, remembering that t can be any integer. And integer equations, so n is also an integer, they are much, much harder than real number equations because you have to think in a completely different way. So to find the smallest possible value of n here, what helps me a lot is to realize that both 27 and 36 are divisible by 9, which means that the entire right-hand side is divisible by 9. So this is divisible by 9. So if the left-hand side has to be equal to something that is divisible by 9, and since 11 is a prime number, then n must be divisible by 9. So we already know that n must be 0, 9, 18, or so on. So I could say n is one of those numbers. And of course, choosing 0 doesn't work because there is absolutely no integer t such that 27 plus an integer times 36 equals 0. So we could try n equals 9. N equals 0 doesn't work. And we could also say that up here we are being told that n is actually positive, so that sort of also rules it out. But what about n equals 9? Turns out that 11 times 9 is equal to 99. And could that be equal to 27 plus 36 times t? And the answer is yes. For t equals for t being equal to 2, we get 72 plus 27, that is equal to 99. So n equals 9 is the smallest value that n can be. That's just part A. Then part B gets really weird, because it says hence or otherwise describe a single geometric transformation. Let's move this here. Applied to set on the Argand diagram, which is really just the two-dimensional plane that is the complex numbers, that results in set to the power of 10. And I mean, it takes a while to even realize what this means, but the best place to start cracking it is to start thinking, well, set to the power of 10, what is that? And can we somehow use what we just found out? Notice that we just found out that set to the power of 9 is just equal to minus I. So it's probably a good idea to say that this is equal to set multiplied with set to the power of 9, which is set multiplied with minus I. Or I would like to write it as set multiplied with e to the minus pi over 4. Then we have to start thinking geometrically. So remember that multiplying complex numbers has a really beautiful geometric interpretation when you think in terms of angles and moduluses. Because when you multiply two complex numbers, you're multiplying their moduli, their lengths, and you're just adding their polar angles, their arguments. So this guy has a modulus of 1, so you don't really do anything to the modulus, and it has an angle of minus pi over 4, which in the old days was called minus 90 degrees. And what we are doing when we are multiplying with this is just that we are subtracting pi over 4 from the angle. And if you think of that in a diagram, Argand diagram for the French people, you could think that, well, our set has an angle of 11 pi over 18. So if we want to draw it really nicely, that's a little bit bigger than pi over 2. So set lies somewhere up here. That's our set in the distance of 1 from the origin, because it has a modulus of 1. Then when you add minus pi over 4 to the angle, it means that you are rotating. I did it again. I said that I was, yeah. So let's do this a bit more slowly. I is not equal to minus pi over 4. That's rubbish. Minus, first of all, I forgot the I, and then the angle, polar angle of minus I is minus pi over 2, which is the angle previously known as 90 degrees. Everything else I said worked. You just have to replace pi over 4 by pi over 2. So we are adding minus pi over 2 to the angle, which sort of means that we're just subtracting 90 degrees from this angle, or that we are taking set and moving to the result that is set to the 10 by rotating 90 degrees counterclockwise. So that's actually what we want to say, that when we calculate set to the 10, it's the same as taking set in the coordinate system, in the two-dimensional plane, and rotating it around the origin by an angle of 90 degrees clockwise. So rotate clockwise by pi over 2 around the origin. And that's what they expect you to answer for part B. finally, question 9 is also really nasty because, well, it doesn't start that nasty, but it just becomes worse and worse as you work on it. And I think it's also among the hardest problems in the test. So let's start and look at it. It seems so harmless in the beginning that we just have this quadrilateral with given side lengths and 2 angles. And question A says find the side AC, so that's this side, in terms of the angle alpha. And that's really just screaming for the cosine relation, for the cosine rule, because we have 2 sides and we need the last side. So we could write immediately that 2 squared plus 4 squared equals AC squared plus 2 times 2 times 4 times the cosine of alpha. And, well, we want to get AC squared, so, or rather AC, so AC becomes the square root of, so 2 squared is 4 plus 16, that's 20. Sorry, like this, 20 minus 16 times cosine of alpha. And that was actually A1. So A2 says do the same, but now find it in terms of beta. And that's really just exactly the same, because if you look at the angle beta, there's again a triangle. We have 2 side lengths, and we need the last side length. So one more cosine rule. This time we just say 6 squared plus 8 squared equals AC squared plus 2 times 6 times 8 times cosine of beta, from which we get that AC is equal to 36 plus 64, a square root. 36 plus 64, that's nice, that's 100, minus 2 times 6 times 8, that is 4896 times cosine of beta. Now it gets interesting, because then it says, hence or otherwise find an expression for alpha in terms of beta. And first of all, you need to be familiar with what this even means. So we want a way of calculating the angle alpha, given that we know the angle of beta. So we're allowed to use beta as an unknown variable in our calculation. And the method is kind of also screamingly obvious. We have 2 different things that are equal to the side length AC. If we put them equal to each other, we have a relationship between alpha and beta. So definitely for A3, we just say that, hey, the square root of 20 minus 16 times cosine of alpha is equal to the square root of 100 minus 96 times cosine of beta. And we just need to isolate alpha here. We can start by squaring both sides, taking away the square roots. So that leaves the same thing without the square roots, and then we can subtract 20 on both sides. I think that's what I can manage by now. So minus 16 times cosine of alpha is equal to 100 minus 20 over there. So that's 80 minus 96 times cosine of beta. And dividing by minus 16 on both sides, we get cosine of alpha. Yeah, let's do that. So cosine of alpha is equal to 80 divided by 16. I think that's even nice. I think that's 5, isn't it? 5 times 16, that's 80. So we get minus 5, because we're dividing with a negative number, and then the minus becomes a plus, and the 96 divided by 16, that's just 1 more time, so that's actually just a 6 times cosine of beta. But how to get alpha? Well, we want to remove the cosine, and we want to use the inverse cosine. And we just have to be careful when we do that, because are we getting the right angle? But since alpha is an angle in a triangle, we know that it's going to be between 0 and 180 degrees. And it's so nice that the inverse cosine gives exactly the one unique angle between 0 and 180 degrees that has the particular cosine value. So it actually works. We can say that alpha is equal to the inverse cosine, arc cos, if you like, of -5 plus 6 times cosine of beta. And that's for question A, which is a pretty nasty expression already. But then question B says, find the maximum area of the quadrilateral. And that means that now we need to calculate the area of the quadrilateral. And it's kind of tempting to say, well, I'm doing it as the sum of the two triangle areas. So the area is equal to 1/2 times 2 times 4 times sine of alpha plus 1/2 times 6 times 8 times sine of beta. But that's a two variable expression, and we don't really know how to find values of alpha and beta such that this thing is maximal. But what we just did was finding an expression for alpha. So guess what? This horrible expression for alpha has to be substituted into this so that it becomes a function of beta. So that means the area is equal to, I'm just simplifying a bit, 4 times sine of the inverse cosine of -5 plus 6 cosine of beta, that's just half of it, plus 1/2 times 6 times 8, that's 24, times sine of beta. And now I don't know about you, you would probably long ago have said this has to be continued in an answer booklet. I kind of feel unable to do that. So I will try and do a little magic trick to get some extra space. I'll just make this a little bit smaller so we still have access to it. And then I can keep working on my expression. First of all, we have seen a couple of times that if you have an inverse cosine followed by a sine, you can actually simplify this a little bit. And I recommend doing it by remembering that if you take a value that cosine has to be, so if you imagine a unit circle, you take a value that cosine has to be, and then you take the inverse cosine, then you find the angle, and then you check the sine of that. You get the number of here. And how are these two numbers related? Well, they're related by Pythagoras, that if this is x, then this number here is the square root of 1 minus x squared. And that means that the sine of inverse cosine of an angle x, that's actually the square root of 1 minus x squared. And that makes the first expression a little bit nicer. So 4 times the square root of 1 minus, and then -5 plus 6 cosine of beta squared. Like that. And plus 24 sine of beta. That made it, in my opinion at least, a little bit more manageable. But of course, we don't get anywhere without the calculator. So from here, we're supposed to fire up the calculator. First thing to do is check that we're working in radians, because of course, alpha and beta, they are now functions. And if we are going to draw graphs of stuff that depends on alpha and beta, we want to work in radians. Then we go here and we define the function. So y1 equals 4 times something to the power of 1/2. That's a square root. And then I move into my bracket and I press insert. And then I focus on writing 1 minus, and then another thing, squared. And then I go inside this bracket and I make sure that, wait a minute, I'm in insert mode. And then this is minus 5 plus 6 times the cosine of my x, end of bracket. That's the first and worst part of the function. Then finally you get plus 24 times sine of x. And there you go. This I need to draw the graph of. So we go to the window menu, and the x's, they're probably from 0, so I go -1 just to have the y-axis, to pi, so let's just go to 4. And the y-coordinates, well, what do I expect the area to be? If you look at this diagram, it's kind of, if you just take a rectangle with sides 8 and 6, then the area is smaller than 50. So having y from -1, again to have the x-axis, and then to around 50 is definitely going to be plenty. And we draw the graph. That's the graph. Oh, and it became bigger than 50. I wonder why. So I regret this. Let's go and say 70 instead. Wait a minute. Something is wrong. It looks as if my function is not being defined in this area here, so I probably typed something wrong. So 4 times a really big bracket that gets raised to 1/2. Inside that really big bracket, I have 1 minus oh, wait a minute, the square. Oh, there's a bracket missing. So the cosine of x has an end bracket, but there is also a bracket here that needs to be ended. So here I need to insert a whole extra bracket, and then all of the -5, 6 times cosine of x gets squared, and that whole thing. I think this is going to improve it's not. Oh, I think I see now why. It's because beta, which is our current variable, is the angle down here. And beta cannot be very large, because the largest possible value of beta is something around 50 degrees or pi over 4. So I'm cheating myself by saying that the angle can be all the way up to 180 degrees. So I would actually go and say the maximum value of x is probably 1. And of course it can't be negative, so we're skipping a whole lot. But then at some point it tops and starts going down a little bit. And I think we can work with this, because what we need to calculate is the maximum. So we press 4, and the left bound, let's move a bit closer, is here. And the right bound, we just go a little bit to the other side here, and then we guess around here. Then we get that the maximum is when the angle beta is actually equal to 0.775, but that's not what they're asking. They're asking what's the maximum value of the area, and that's the y coordinate. And it says right there that the max value, so we can just write here, the max value on GDZ is that the area is equal to 19.6. And do we have units in this question? No. So no units. The maximum area is 19.6. And that's it for this last part. I hope you've enjoyed the show and that you have a really nice summer for the rest of July, and see you after the summer break. Take care.